Hi everyone, I'm Prateek. Welcome to this course on JavaScript functions. This course will teach you how to write modular, concise, and reusable code with functions. Before we dive in, let's review what we'll be covering in this module. First, we learn what a function is, why we use them, and how to write and run them. Next, we introduce arguments and how they let us pass information to our functions. We also cover how the variables in a function are scoped and how to access them correctly. Then, we look at immediately invoked function expression, also known as the iffy pattern, and compare it with regular functions. Next, we introduce closures. A closure is a combination of a function and its context. The context contains the variables defined in the function as well as those that are visible to the function when it was first defined. We'll look into it in more detail later on in the module. Finally, this course is filled with demos, so I really encourage you to code along. The more you practice, the better you will understand these concepts. Let's get started. Let's take a look at the development environment we'll be using for this course. All the demos in this course will be done in Visual Studio Code, which can be downloaded from code.visualstudio.com. To get the most out of this course, you should already know the basics of JavaScript. Things like how to use variables to store information, the different data types like string, numbers, and Boolean values, and how to write conditional statements and loops. There are several poolside courses you can look at if you need a refresher or you are completely new to JavaScript. Once you have downloaded and installed Visual Studio Code, open the editor. Let's briefly review how we will run our demos. First, install the Live Server extension by clicking the Extensions tab on the left. This will let us change our code and view the output at the same time. Next, we have two files in the same directory. We have an index.html file with some template code, and in the body tag, we have an h1 tag with the JavaScript demo and a script tag that references the app.js file. This template can be easily generated in Visual Studio Code by typing exclamation followed by the tab key, and then you only have to reference the app.js in the body as shown here. You can right-click and select Open with Live Server, and this will open up the browser displaying the content of your h1 tag inside the body tag. And any changes you make and save in your HTML file will immediately be reflected in your browser. Since we'll be printing our output to the console, you should open the developer tools in your browser as shown here. Next, we look at this empty app.js file referenced in our index.html file. This is where we'll be spending most of our time in the demos. If you type console.log hello world here and save, it shows up in the browser console. With the environment setup out of the way, we are ready to move on. Functions are at the very heart of JavaScript. They are a powerful tool that let you create reusable chunks of code. They make coding faster, easier, and less error-prone. So let's look at a simple definition of what a function is. A function is a block of organized, reusable code that's used to perform a single related action. In other words, it's a set of statements that perform a task or calculates a value. To use a function, you must first define it. Here's a simple example. A function declaration consists of the function keyword followed by the name of the function, a list of optional parameters enclosed in parentheses separated by commas, one or more statements that define the body of the function. These are enclosed in curly brackets as shown here. Note that the function definition by itself doesn't really do anything. In order to run a function, you have to invoke it. This is done by calling the function as shown in the statement here. You include the function name, followed by parentheses and a semicolon. The output here would be hello John. Another thing to note here is that by default, all functions return a value. In our example, the returned value is undefined. So how do we go about returning a value? We do this by including the return statement at the end of our function body. This is similar to our previous example. Instead of printing the hello John string to the console inside the greeting function, we return it. This returned value is collected in the message variable where the greetings function is being invoked. We then print the message variable to the console. Before we look at another example, let's clarify the difference between an argument and a parameter. An argument is a value that we pass to the function when we invoke it. A parameter, on the other hand, is a variable that we list as part of a function definition. In this example, we define a function called sum that takes in two parameters. We invoke the sum function with arguments of values 2 and 3 and assign the returned value to the result variable. Finally, we output the value of result variable to the console. In this example, we have a function named greetings with one parameter name. In the function body, we can reference this parameter just like any other variable. We invoke this function with the argument name whose value is initially set to John, and then we invoke the same function with the argument Mary. Can you see the flexibility arguments provide us? This is especially useful when we get to more complex examples that do a lot more than printing to the console. Now let's look at the arguments object. There may be times when you need to invoke a function with an indefinite number of arguments. The arguments object allows us to represent them as an array-like object. It's array-like and not exactly an array because it has a length property and all values are indexed beginning at 0 index. However, it doesn't have other built-in array methods like for-each and map. In this example, we define a function that prints all the arguments that are passed to it. First, we invoke it with 5 arguments, and then we invoke the same function with only 2 arguments. ES6 allows us to achieve the same result using rest parameters, and we will revisit this example in one of the subsequent modules. Let's see some of these examples in action in our demo. To begin, let's take our first example from earlier. Here, we have the greetings function definition, and notice how we have to invoke the function to get the output in the console. Next, we have the same function, but we return the message instead of printing it to the console. One thing to keep in mind here is that when your function is returning a value, you should assign it to a variable, as we are doing here with the message variable. If you don't, you simply lose the returned value. In this example, we are calling the sum function with values 2 and 3. The result 5 is displayed in the console. What happens if your number of arguments and parameters don't match? Let's try it out. We invoke the sum function with only one argument. The output is NaN, which stands for not a number. This is because when the sum function doesn't get any value for num2, it defaults to undefined, and JavaScript evaluates the addition of num1 and undefined as not a number. This is our example from earlier with the arguments object. We are able to invoke the same function printAll with different number of arguments. The output is displayed in the console. It's important that we understand the lifetime of variables within a function. In this example, we have a function greeting that simply declares a variable message and assigns the value hello to it. We invoke the greeting function first. When we try to access the message variable, we get a reference error. This is because message has function scope, and as soon as the greeting function completes execution, the message variable is no longer available. In other words, message is now out of scope. Here's another example. We have our greeting function with the message variable initialized to the string hello. But we also have a nested function say hi. This is a function expression in which the function hi is set to the variable say hi. In the nested function body, we log out the message to the console. We add a statement invoking the say hi function at the end of the body of the greeting function. Finally, we invoke the greeting function to start its execution. Notice that when we get to the line where the output is being redirected to the console, the message variable is still in scope, even though it's not declared inside the nested function. Whenever a function cannot find a variable, it looks to its parent function. So it's able to find the message variable right here. Moreover, JavaScript will keep looking at a parent and its parent for deeply nested functions, either finds the variable or you'll get a reference error. Let's look at one more example. Here we have the same function as before, but this time we declare another variable message inside the nested function sayHi. We set it to the values hi, close the nested function body with a curly brace. We then invoke the sayHi function before logging the value of message to the console. So you could use the same variable name as a variable in the parent function, but it will go out of scope as soon as the nested function completes. And you get the value hello in the console. Let's see function scope in action in Visual Studio Code. Here we get a reference error since message variable is declared inside the greeting function. If we move its declaration outside the function, we can see its value in the console. In this example, we declare another message variable which is completely different from the variable by the same name in the parent function. As discussed earlier, when we print its value outside the nested function, we get the value hello and not hi. However, if we override the message value, then we get hi as we are referring to the same variable. Block scope was introduced in JavaScript in the ES 2015 release. Before we look at an example, let's clarify what exactly is a block. When we say block, we are referring to the code placed between curly braces. So with block scope, we are talking about the lifetime of variables within the curly brace of an if statement, a while, or a for loop, or any set of curly braces other than a function. Also, note that the variables declared with the var keyword or created by function declarations do not have block scope. Examples will make this clear. We have an if statement that evaluates to true, and inside the body of the function, we declare and set the value of count variable to 100. Next, we print the value of count to the console, but get a syntax error. Why? The count variable was declared inside the if block, and as soon as the code block execution completed, it went out of scope. This is similar to the last example. Here, we are declaring another variable with the same name as the variable before the if block and setting it to inside if block. Then, we lock the message variable and it prints inside if block. But when we print the message variable again outside the if block, it prints hello. So as you can see, we are allowed to reuse variable names within code blocks, but they override the value of message while the block is being executed. Once the execution moves outside of the block, the value is still what it was before the if block code execution started. Let's see this in action in our demo. In our first example, as we saw earlier, trying to access and print the value of count results in a reference error. However, if we change the type of count to var, then we get 100. This shows that count no longer has block scope. Therefore, it is always a good practice to use let instead of var to declare your variables. Next, we take a look at immediately invoked function expression, also known as the iffy pattern. The iffy pattern lets us group our code and have it work in isolation independent of any other code. It stands for immediately invoked function expression. Let's break it down. A function expression lets us define a function and assign it to a variable. Immediately invoked means invoking the function immediately where it's defined. Let's see an example. Here's a regular function that we have already been working with. In order to run it, we call the function name followed by parentheses. Next, here's the iffy function that accomplishes the same thing. However, note that it doesn't have a name and it's completely inside parentheses. Finally, it has an opening and closing parenthesis appended to it followed by a semicolon. This function will be invoked right away. To make it a function expression, we just assign it to a variable or use it in some other expression. We will review this with an example, but before that, let's take a look at closures. We already looked at how variables and nested functions go out of scope once the function or block they are contained in completes execution. However, there are times when we would want to hold on to them even after a function is executed. Closures allows us to do just that. Here's a familiar example. We have a variable greeting that is set to an IFI. The body of the IFI contains a variable message set to hello, and another variable getMessage set to an anonymous function that just returns the message variable. If you try to print greeting.message, we get undefined, as the message variable is out of scope. So how do we prevent message and getMessage from going out of scope? We use closures as shown in the next slide. This is same as the last example, but we create a closure right here. We return an object with the property getMessage, and the value is the function getMessage. Typically, the property and value names are the same, but they don't have to be. This object is what gets assigned to the greeting variable. At the very bottom, we log the greeting.getMessage output. Here's another example of when we would want to use a closure. We have a setup counter function with one input parameter. Inside the body of this function, we return another function counter that simply increments the input parameter val. Next, we invoke the setup counter with the argument 0 and assign it to the variable counter1. We then invoke the counter1 setup counter again with the argument 10 and assign it to the variable counter2. Finally, we invoke the counter2 function and print the output to the console. This time, we see an output of 10. In this way, different invocations of setup counter function produce different functions with their own context and variables. Let's run this example in Visual Studio Code in our demo. We define our setup counter function as discussed earlier. Next, we are setting up two functions, counter1 and counter2. Each of them have their own environment and variables, and anytime we call either counter1 or counter2, the variable that was initially set up in their context is incremented. Let's run it and we can see the expected output. Calling the counter function again keeps incrementing the value returned. This brings us to the end of our module. Let's review what we covered so far. We introduced functions, what they are, why we need them, and their syntax. Next, we looked at how arguments let us pass information to functions, and also how to use arguments object to iterate through the list of input parameters. Then, we looked at function and block scope, and why it's good practice to use the let keyword instead of var. Finally, we looked at how powerful the IFI pattern is and how they can work with closures to hold on to variables declared in a function even after the function has completed execution. In the next module, we'll take a look at arrow functions.